Hello, everybody. Thanks for joining us once again. I'm Dirk, CEO of Parallaxis, doing our ongoing podcast series. Today, we have with us a few gentlemen who will be exciting I'm sure you'll be excited to hear what they have to say. We have Tim. He is the founder and CEO of Dolt, who has been in business for 7 years. He'll be telling us a little bit about Dolt and what they do here in just a minute. And we have Dan, who is a regular here on our podcast. He is a advisor to us here at Parallaxis, master's degree from Notre Dame University in data science. And if you've been watching them, yep, go watch Rudy, like we say every time, because it's a great show and a great movie. So anyway, we're gonna go ahead and just jump right in. And as a starter, this one's to you, Tim. Everybody that's listening to us might not know what Dolt is, Dolt Hub. So if you don't mind, maybe just take a few minutes, kind of tell us what is Dolt, why'd you start it, and why is it revolutionary?
Sure. First off, thanks for having me. It's always great to talk about Dolt. It's been spent the last 7 years building it, so it's always nice to share the good news. So Dolt is, and yes, it is called Dolt, like idiot. We get a lot of questions. I'll explain why in a bit. Dolt is the world's first version controlled SQL database, and so think Git and MySQL had a baby. So you get all the Git features you know and love: commit, diff, branch, merge, push, pull, clone, every Git idiom on SQL tables instead of files. So this is useful for a number of purposes, but the I think we're here to talk about data science. The idea here is if you've, say, cleaned a bunch of data, you can do that on a branch away from the main copy. You can get a human review on it. You can do a pull request just like you do on GitHub to make sure that what you've done is correct. So you get all of the Git and GitHub workflows you know and love on tables instead of files. Tables can be extended to any structured data because modern SQL databases can take JSON, they can take XML, et cetera, et cetera. There's kind of two modes to run Dolt in. One is Git for data, which is kind of like a command line, and that's popular, but not as popular as just running Dolt as if it was a MySQL replacement. So you can just drop in MySQL anywhere, or you can drop in Dolt anywhere where you would run MySQL, and you can connect any application that connects to MySQL using that can connect to Dolt using the same client. And so all the things Django, SQL Alchemy, Pandas, any tool that you use can just work directly with Dolt. The Git stuff is exposed as system tables for reads. So you select star from Dolt log. The write operations like add, commit, these are exposed as procedures. So you call Dolt commit. And so I'd say if you're familiar with Git and SQL, it's pretty obvious how it works.
Cool, thanks for that, Tim. Appreciate that. So, quick question. So, you mentioned, the idea of merge pull requests for data changes, and that's a unique thing to Dolt. How have you seen this help companies in simplifying or streamlining their processes?
So we have a number of use cases. There's video games, there's healthcare, but since I'm on a data science podcast, I'll focus a little bit more on the data science use case. The main use case in data science that we see is as a machine learning feature store, and data scientists use the Dolt features to uh, give themselves model reproducibility, model explainability, and then finally collaboration across a wider variety of data scientists on the same data.
Yeah, when I first saw Dolt, it was amazing to me that it didn't already exist. I know it's a huge and hard problem to solve, but I love the ability I came to data science as a software developer. That was my background, and the ability to version the data for the models I'm developing and then get a peer review on that data, I think is amazing because it helps data scientists follow a more traditional software development workflow, which aligns better with how I'm going to deliver the application or deliver this microservice, which is the model, to the application. So I see huge benefit as part of your data science workflow, but also as part of your platform engineering workflow.
Right. Like the best example, and I go to this often. So if you've ever met me at a conference or in person, might have heard this. So I apologize to listeners that know me. We've been working with this company called Flock Safety. I think they told us they adopted us when they were like fewer than 10 data scientists. If you don't know of them, they hang cameras in neighborhoods and then do anomaly detection on the video streams and if there's a crime that happens in the neighborhood, they work with the law enforcement to make sure
Yeah.
that the problem's solved. So they build custom machine learning models, mostly for license plate detection, but they've said they've expanded into audio, listening for broken windows, all this. So they put all of their training data into Dolt, and when they originally picked us up when they were very small, we were like, "Oh, are you using diffs? Are you using branches?" They're like, "Nope. Basically, we just want model reproducibility. So whenever we train a model, we cut a tag." And so, for those not super familiar with Git, a tag is just a named commit. You call it version one, and then you can always know that when you refer to version one, that whatever was in version one won't change. And so they're like, this is perfect for us because we just keep changing data whenever we train a model, we make a tag, and that gives us reproducibility. And then
Yeah.
fast forward, this is maybe 4 or 5 years ago now. Fast forward to now, last time I talked to them, they said there were over 400 data scientists. They were using it for collaboration. They had whole teams working on separate branches. But the most interesting and sort of salient example of how it was really helpful for them is they had a problem where they had, unbeknownst to the data scientists, they had a big dump of Hawaii license plates put into their training set. And so the model was over biasing. It was saying there was Hawaii license plates obviously in the continental United States, you very rarely see a Hawaii license plate. And so they got reports, customer complaints that they're like, what the heck? It just keeps saying it's Hawaii. It's clearly not. And so they did a diff between yesterday's model and today's model at the tags and counted the number of Hawaii license plates. And it turns out there was 50,000 new Hawaii license plates in the data set. So they just rolled it back. And they immediately knew what the problem was. They said without Dolt, they said this would have taken them weeks, and it was seconds. It was like basically obvious from the diff what had happened. And so that's a really salient example of how versioning can really save you a ton of time and energy. And anyone who's worked with Git and software has a similar anecdote with code. So
Yeah, I'll echo that, and you take that, you move that into high compliance environments like finance or telecom, the
Mm.
ability to track the data that you trained your model, and if you store your model hyperparameters as part of your source code, which you should, you now have the ability to go back to exactly what was that model trained with, what were the hyperparameters used to create the model, and you should be able to create that model if you need to. So now you have the ability to, if you have to go under audit and let's say that you were in finance and it made a recommendation, you have the ability to go look at what were the most likely features that drove the model to go create that recommendation. It's huge, just not just from a utilization standpoint, but also from an audit and accountability standpoint.
piling on there, we always say one of the cool things about Dolt is you get an audit log online of every cell in your database going back to inception. Who changed it, when, why, right? Think about how powerful that is in these high compliance use cases. Why finance comes to you or compliance comes to you is why is this number 10? You can literally say it was always 10
Yeah.
or Bob changed it to 10, right? That's that's stepping a little bit outside of the ML use case, but we think that that's another powerful feature.
So I'd love to get your opinion on experimentation. So as I'm building a model, as I'm looking at the different kinds of models I could use, like going with old school traditional categorization, or as we go into the modern day generative, and I'm experimenting with different models. How do you see Dolt fitting into that experimentation process?
Great question. The There's a number of vectors here, and vectors pun intended, I think, on a data science podcast. The I'd say the core answer to your question is branches in source code and in Dolt are an ideal platform for experimentation. When you make a branch, you get your own separate copy. It's not going to hurt anybody. You can do whatever you want. Dolt also has the ability to clone, so you don't even need to make the branch on the database itself. You can make a clone to your laptop, make a branch there. No one can even see it. No one needs to know about it. You can delete to your heart's content. Just having that ability to have an isolated copy either on the server, the database server itself, or locally on your laptop, and then be basically having free reign to change, add, delete without affecting others. If you've worked in data, and most of the people listening to this will have been working for years, you usually do that by writing a query and downloading it as a CSV and then working with it in pandas. The problem with that is you can't update it. If let's say you do a bunch of cleaning, and what ends up happening is it's just better. You can just take that result and merge it back in, or create a pull request and have it human reviewed. You get a lot of extra features and human in the loop style features that are powerful with even agentic workflows these days. The second thing you touched on is like how is the Dolt evolving as the types of models that we're training are changing. We tend to be there's a couple dimensions here. Dolt is very useful for structured data, and so think bounding boxes and labels, that type of information. Unstructured data, which is generally used to train large language models, is not necessarily an ideal fit for Dolt. Generally, I think for most of the foundational models, the goal is throw as much data at it as possible and let the gradient descent handle the complexity of this. I think once we've gotten to the end of the data rope, so to speak, where basically all the data on the internet is already in every model, I think you will get to a fine tuning stage where either we'll be adding additional training on top, or we'll be using these models in different ways. And I think that's where Dolt will be, again, come into its own as a useful tool anywhere where you're trying to, where you have humans managing or changing or experimenting with data. It adds a ton of value. Storing all the data on the internet, probably do that in another place.
So you touched on something that I wanted to ask you about. That Dolt has recently released the ability to do vectorization and function as a vector store. So when we look at other databases, Chroma, whatnot, and that are already out and people are using, what's the benefit of using Dolt instead of like a Chroma? How do you see it fitting into the ecosystem of vector databases?
Vector databases are really interesting to us, just as a technical concept. The idea that you can parameterize an image or a block of text and then be able to do universal similarity search across the images and text within your database. It's an extremely powerful feature. I think beyond retrieval augmented generation RAG, it's just a useful tool. We've spent a bunch of time implementing full text indexes, which are worse, and take a lot longer. So just the idea that you can get like similarity search across text or image blobs into databases. It's super interesting and cool. Dolt implemented vector search in alpha in January. We did it before MySQL, but after MariaDB. So those are kind of they define the syntax for us. So we followed MariaDB syntax. The really interesting thing about vector search and having that version with Dolt is kind of the same thing we've been talking about with other use cases, but applied to vectors. It's like, okay, I'm going to use Anthropic's new model to build vectors for this text, and I wonder if that works better than Anthropic's old model or ChatGPT. I can do that on a branch. I can have my application literally A/B test against each branch, have my users tell me which recommendation is better, or which and then which result of this vector search beneath this rag, like which did it respond better with this to your prompt with A or B. Have them run that as an A/B test, and then merge if it does perform better, merge the model, those vectors back into main, and then just have it run as your production model. So that experimentation is really interesting. There's even if you're not going to do an experimentation, I added these 100,000 vectors yesterday, and all of a sudden my RAG is performing worse. You can roll back to before then, and then create a branch and start debugging what actually happened with these new vectors. Maybe you used a different model, or you get a lot of powerful capabilities around versioning of these things. The thing it's more, I think. So a more interesting question is like, what's not interesting about versioning of vectors? Because obviously, I think it's obvious. Like you're going to want to roll back, you're going to want to branch. The diffs are really kind of useless, right? These are just strings of numbers. Like no human is going to be able to look at a diff between two branches and be able to discern anything useful from that content. But other than that, all the versioning features are extremely interesting.
A thing I would love to see, and I may go try this now that I literally just thought of it, is that using the vector database to do semantic similarity between two data sets, right? In the past, we had to do analysis on surveys, and trying to understand the underlying behavior, we'd use semantic similarities. It'd be very interesting to be able to create a branch, use different tokenizers, be able to do that semantic similarity comparison to see what would be different in how you group them together, what the semantics are, and really get to the underlying causes for some of the surveys. I think that might be a neat little project to go do.
Yeah. Well, since we are running out of a little bit of time, maybe one more, last question, bit of a softball question for you there, Tim. Kind of obviously you're the parent of your company, the co-founder. What would you say is your favorite feature of Dolt? And maybe even what would you think is the most powerful feature for someone? Most of our listeners are data science folks, data science teams. Maybe what would you think is the most powerful feature for people in that realm of the world?
The first time you run update rand, like update table set x equals x plus 1, limit rand 5, right? So you're just basically like selecting 5 random keys to increment and then being able to just run Dolt diff and being able to see what changed. You're like, the first time you do that, you're like, I kind of think this is how these things should just work. Right? So for me, it's the simple thing. I like to say that databases are the last place where there's no undo button, right? Where undo could take days, right? And so that it's the simple things for me. As we get deeper into this, there's performance and all, and these like getting to be MySQL parity with MySQL on performance is a big accomplishment, um, and so there's like more esoteric things. But I think if I'm coming to Dolt and I'm trying it first time, I would run an update query or an insert query and then just run Dolt diff and just think of just how useful that is as someone who runs SQL all the time, right? And so I think it's the simple things that really show how powerful it is. The That being said, you know, it. I'm a little biased. I've been. I remember the first time I saw the original version, and my mind was blown. So and it's been 7 years. I continue to be shocked with a lot of some of the use cases. So
That's cool. I could have used this about 20 years ago when I worked for Quest. And on the first day of my job, this is not a lie, I put a view on a table and took down production for all business markets users. And then it took about 3 days to figure out why it took it down and get it back up. Thank you, Quest, for not actually firing me on the first day of my job when I did that. Worked there for 8 more years, so thanks for that. But no, I could have used something like that for sure. Well, guys, this is fun. Tim, thank you for joining. Dan, thank you again for joining. And this is, I think, the fourth or fifth one you've done with us. For those of you, actually, let's do this, Tim. For those of the people interested, what's Dolt's URL? Where can they go to find out more?
dolthub.com, just like GitHub. There's Dolt itself. That's like think Git. There's Dolt Hub. That's a online collaboration platform where you can find open data. If you're into data science, we have our most popular data sets are U.S. stock market related options data, earnings data. So if you're listening to this podcast to learn data science, it's good. Grab those. You get real production data to play with.
Cool. All right. We'll go there, folks. Tim, thank you. Dan, thank you. See you guys soon.